Hey, good morning. Good morning, Mohammed. Good morning. And the rest of you, please switch on your cameras. We can get started. Okay. All right. Great. There's only 11 people. What's going on? Um, are you guys, in touch with your other classmates at all and outside of class? That's a pity. Back when I went to school, we were in a group and we can all talk to each other even outside of classes. I don't know what the hell is going on here. But even though it's on Zoom, you guys should reach out. You should reach out and contact your other classmates and say, hey, what the hell is going on? I mean, you could fail. You could fail this class for not attending lectures or it's like that. I don't. Why do people enroll in classes if they're not planning to attend? All right. Okay. Well, today we will talk about functions because next week on we'll be doing objects and starting to bring everything together. By the way, I wanted to make a note because we're still waiting for people to join. I wanted to say about these things projects that we do in class and then we share on the Reddit. So far, the only people that have done this are, Hannah, Erica, Namrata. I don't know, maybe Omar. Where's Omar? I think he started questioning again, but he's not here in class. I hope he's okay. Okay. Again, somebody should reach out to him. One of your classmates got COVID and nobody cares, right? And Omar said, I think Omar said he had COVID or he got COVID. Okay. So you guys should reach out to him and say, hey, how's it going? Okay, but I think he's okay because he started questioning, but I don't see him in class. So you guys should find out what the hell is going on. All right. So only some people are actually picking up these very interesting, juicy, and I think important challenges because that's where the learning in any class is. When a teacher takes some problem to a certain place and says, okay, well, I'm going to leave it here for you guys to finish off. Doesn't mean, well, we got to that much of the proof or this thing in class, but that's the end of class. We don't have to think about it anymore. Then that's the end. Okay. The whole point of a teacher leading students up to a certain point is that, well, this part is the hard part, and then there's a little bit more that you need to do that will basically seal it in for you. And then if the students don't do that last part, then everything that's been in the bucket will leak out. And then you're back to square one. What is the point of doing these things? And also, I wanted to make a point to the most recent one that Erica posted. Really cool. And I actually I played it on my phone. Okay, I wasn't even at home. I got a bing on my phone and I said, hey, Erica posted something. Let me try it out. And it was very nice. But one thing really struck me. And I thought it was a very nice change. And even though it wasn't really I would say a technical change, but it was a fundamental change to the app. And I think Erica, with her background in neuroscience and all, master of sleep, okay? Right? So I think the 3 seconds or whatever it is that Erica introduced, saying, get, set, go, like a running race, that makes a world of difference, okay? Because without it, the game is not even half playable because, it just starts off and people are caught off their guard. But just making that small change there, saying, okay, well, it's going to start 3 seconds. That's all, right? And that is what a good product manager brings to the table, okay? They know how to do these things. And they'll play it and they'll look at it from the user's point of view and say, I've done it. It all looks good, but there's something in here that is basically irking the user. Okay, what is it that is a problem to the user? And then putting themselves in the user's shoes, think, all right, that is what I need to fix. Okay, and then go back and fix that. Or, if you're a full-fledged product manager, you'd say, I played it, but, if that thing is there, it'll be nice. Okay, those are the things that are really, really valuable in the completion of a successful product. I'm not talking about just a program. The program is maybe 90% of the product, or or 50%, depending on the thing, right? But the complete product involves a program, and then market research to see, what do people want? My program does this, but people don't want it. There's no use. Okay, and then even if you deliver what people want, you need to look at, is it delivered in the way that people want it? right? So maybe this is what people want, but they don't know how to use it properly. Okay, in order to get the full benefit, they need to. That is what people pay the product management people for. Okay, to actually get a handle on. It's interesting in its own right, but in my I don't know, in my opinion, a good product manager in technology needs to be also a good engineer. Okay, meaning they need to know how to think, how things are done. Okay, at some reasonably low level, not all the way down to the bare bones, but they need to know. And so these are skills that you can pick up to along the way. So please do take these opportunities to take all the code that we're developing in class. Make variations and share them in the forums. I really liked the stuff that Hana and Namrata and Erika posted. Okay, so all right, so today what we'll do, yeah, we'll play with functions. And I was thinking, yeah, all right, so we'll play with functions. We'll just come up with a bunch of programs, but a bunch of little functions that we can write, and along the way we'll figure out something interesting to do with the functions. Okay, and we'll figure out something. Okay, I think we have a lot of skills already, I think, because we know branching and looping and things like that. We know how to print a line and then go back to the beginning of the same line too. Yes, yeah, all right, good. All right, so yeah, I think we have and then we know sleep. All right, we know sleep, and then we know how to measure time. At the microsecond level or millisecond level, and also at the second level, right? So we have all the requirements, all the bits and pieces needed to make something interesting. So we just need to see if we can get something happen with those things. Okay, so how about today? So someone agreed to code today. Well, yeah, I don't know, was it Karthik? Karthik, did you agree to code today, or do you want to code next class? Can hear you. Your microphone is switched off. All right, well, it looks like he's making an excuse anyway. Oh yeah, I can hear you, Karthik. Okay, so it looks like he can do it. But who else? Someone else lined up also.
Oh, there we go. Does it work now?
Yeah, it's working now.
Oh, thank God. Yeah, I can.
Yeah, next class?
Yes, I'm very, very sick right now.
Oh, all right, okay.
Yeah, I think it would be best if next class. Yeah, middle of the chills and everything. So I think that next class would be best. I'll be better by then.
Okay. How about wow, everybody here has coded except Matt. Yeah, Matt and Minghua haven't coded, and Yu Yang. Hannah, you can wait. Okay, you can wait until week 6 or 7 maybe. Week 7 maybe we'll have some interesting things with pointers and everything. Okay, I think that would be fun for you. Okay. Yeah, Matt. Okay, great. Thank you for volunteering. Okay, and please do, before we leave this topic, reach out to any classmate you're connected to, right? Or even if you're not connected to, pick a random classmate on Canvas and say, hey, I didn't see you in class today. What's going on? Please come, because we're doing lots of important and interesting stuff. Okay, just send messages out to your classmates and have them all turn on. Okay, Matt, whenever you're ready, you can pick up the screen and share a private browser. Okay, either private Chrome or incognito Chrome or something like that, and then we'll start coding. And we're just making do with just the online compiler. It's almost the middle of the quarter and we're still working with online compilers. We haven't started working with IDEs. Yeah, I'm pretty sure you have to use IDEs for some of the harder things that you'll do in the quests, especially in quest 9 and all. I think it'll be easier 8 and 9 to have an IDE.
What's the website again?
You can just Google for online C++ compiler, pick any of them. And is this a private window, by the way, Matt?
It's a guest.
No, it's not guest. You're logged in as guest. You have to have, no, you can, what you have to do is close this window, and then you can open what is called an incognito. Close this altogether. You can have another new window there. Yeah, close this window altogether.
Okay. Or is it here?
This is a Mac or a PC? I don't even see your controls, the window controls.
It's a Mac.
Where are the window controls? I don't even see the window controls here. How do you, where's the file menu for, is it Safari or Chrome?
Chrome.
Okay, so where is the new incognito window? We need a new incognito window. How come you don't even have a new incognito window?
I don't know.
Oh, this is not your own Mac?
No, it's not.
Is this a lab Mac or something?
Yeah. Or no, it is.
There, okay. Under the file menu, you'll find incognito, new incognito window.
No, I don't see it. It's just new or it's blocked.
And it is your own Mac, you said. Okay, try Safari.
Oh, new project. Okay.
You got Safari?
Yep.
And incognito too? Private. It's called private in Safari.
Yep.
Oh, why would private be blocked in Chrome? There's some kind of setting there. I've never encountered it, by the way. Okay, so and then when you're ready, share after you share the screen, put the standard comments on top. Comment, clear off everything. Oh, we haven't got the online GDB yet, so go to online C++ compiler, any of those sites, and Control A to select and delete everything. Control A, delete everything, Control A, delete everything, and then collapse the blue side panel by it's the side panel, the left.
Oh.
Now put comments on the top saying class code for what is today's date? 6 or 7 or
I think it's 7, right?
Yeah. 7. And then we're going to you can say I'm going to play around with functions and see if we can do something interesting. Okay, so since I'm playing around with functions, let's say playing around with functions. Yeah. Right. And then you can do a standard hash include IO stream, and then using namespace standard, and then your int main, the boilerplate. And then what we'll do is, and while you're doing the boilerplate, someone else should also feel free to walk them through the boilerplate, int main and all these things. I'll try and think of what we can do. Just to 1 minute. Okay, it's someone please do. So do a function. Let's say we make a function to print
like
a
return 0, maybe.
Oh, you're done already. I'm sorry. I was still thinking. I wasn't even looking. Sorry. Okay. All right. So I think I have a reasonably good handle on what we can do. Well, we don't have a full entertainment experience yet with the game, but I think something will shape up. Okay, because we have all the bits and pieces. Okay. All right. Good. So here's what we'll do. What we'll do is we'll write a function. Okay. We are going to write a function that will print a line on screen, and then get back to the beginning. Yeah. All right. So essentially, you're going to get given a string. All this function has to do is print the string and with a /r at the end. That's all. Okay. /r. But then the thing that we have to keep in mind is that if ever the program uses cout and an endl, either an endl or what is it, a new line or things like that. Okay, if ever the program uses one of those things, then that screen, that one-dimensional screen, will be frozen right there, and then a brand new screen will be opened under that. Okay, so I think that's the effect that I can see in my mind, but we'll see if that happens. Okay, so let's do a function right on top of main. Okay, so open a comment right there. Yeah, thank you. That's great. That's great. Fantastic. Okay, yeah. All right. Open a comment saying a very simple function that will print the given string and return to the beginning of the same line. That's all. Okay. And does anybody know how to do this? Because it is very, very simple. Yes. All you have to do is you're going to create a function. I can help you with the signature of the function. And then along the way, we're going to experiment with various things. Okay. We can change the signature, see what passing by references and so on. And along the way, I will also have a chance to describe what goes on behind the scenes when you call a function. And it's important. You don't have to know this to pass the exams and all. But I think it's important to know exactly what happens, especially from a computer architecture point of view, where you call a function and then some magic happens. The function's code runs. How does it run? Okay. And then after the function's code runs, so you come back. How do you come back? All these things are very important to know, right? So now what we'll do is make this function, make it a void function. Okay. It's not going to return anything because all it has, right? And it's a void. And then I'll explain all of these. And we'll, put all the explanation in the comments up there because a lot of students are missing in class. They can look at the comments and see what's going on. So void, let's say, and let's call this function void print 1D underscore screen. Okay, print 1D screen, and then number 1D, and then put underscores before the one. So 1D, right? One upperscore D, uppercase D, right? So and then that'll be uppercase D. No underscore before the D. 1D. This is one dimensional. 1D, like 3D, 1D. Yeah. 1D screen. 1D screen. Okay. Now let's flesh out the comment above the function, so we know what the function is going to do. All right. So the one-dimensional screen is simply a horizontal line of text, right? So just write that there. One-dimensional screen, horizontal, one-dimensional, 1D screen, 1D, one-dimensional screen, 1D, and then within brackets you can say 1D, so that people know when they look at the function name. 1D, right? A screen is simply a horizontal line of text. One horizontal line of text is simply one horizontal line of text. That's all. Okay. And here, this function is going to get given a parameter. Okay. And the parameter is basically just going to be, we'll call this string, the screen that needs to be printed. Right? No, not the screen. If you call it. We'll call we'll just call it a string, okay? Or let's just say contents, all right? So inside of the parentheses for print 1D screen, there you go, right? So you can say string space contents, right? Contents. And all this is going to do, as you know already, is on the next line, it is simply going to do cout left shift contents and then end it with a /r. Yeah, thank you. Right? No, backslash. Okay. Okay, semicolon at the end. On the next line, you need to do an explicit flush because /r does not automatically flush. So you say cout.flush. Okay, that's all. It's a very simple function. And it prints a screen. Now we can actually test it too, right? So we'll go to main and test it. And then after we test it, I'll also explain what's going on and things like that. Background, FLUSH. And then open, close. Great. Okay. So now let's test it in main. So if you go into your main, there's actually two. Are there two blank lines above main or just one? No, there's two. There's two. You can get rid of one. All right. So here, what we'll do is we'll try something. Okay. So we'll do print. Print someone's name. Maybe print someone's name. Print someone's name. I don't know. Print your own name. Maybe print your own name. Okay. And then we'll do a sleep of 2 seconds. Okay. Sleep 2 seconds after that. On the next line, you can say sleep 2 seconds.
Like sleep.
Yeah. Sleep 2 seconds. And then next, after that, what we want to do is, right, here's, right? So you want to say print 1D screen. Let's print, man, just 4 letters. You know what? Don't print your name first, okay? Let's print Elijah's name first, okay? Print Elijah, okay? Elijah's name first. No, Elijah, right? He's right there on screen, right? So you can write Elijah's name, right? Now, after that, now you can print your name. Now print your name. Right? And then after that, hit a new line, right? Hit a new line. Oh, no, you can say see out new line after that. See out new line. Now, because we're doing this, and we know what's going to happen with the new line, but we didn't actually put it in the comments about the function. So let's add that in the comments about the function. So on line 11, which you have a blank line there, just open a comment right there and say note. If the program sends out a new line to the console, then the screen will be frozen and frozen at the current line, and a new screen will be opened on the next line, and a new blank screen will be open on the next line. Okay, I think that's a behavior that we'll see. Yes, that's the behavior we'll see. Okay. You can take the second half to the next line, so you can break it up into two lines. The long comment, you can break it up into. All right, great. Okay, so this is what we're going to do now. We can run this in your head, right? Before Matt runs it, you can run this in your head and see what is going to happen. Okay, so what do people think is going to happen? This is actually the most interesting part of CS2A. Essentially, when we do something, don't run it and not run it and say, what is going to happen? And then we all take guesses. That is actually the most interesting part of these classes. So let's take guesses. What is going to happen? What do you think is going to happen when Matt hits the run button? Anybody can take a chance, okay? Anybody can take a guess at what they think the output is going to be, right? The entire behavior of the program from the run until program exited with code 0 or something, right? So until then, what is the behavior that we expect to see? Take a guess. It doesn't matter. It doesn't matter if you're wrong. There's going to be many guesses, hopefully, and then we'll see which one is right. Yeah, just like the Price is Right. Okay, so we can see which one's closest to what is happening. Go ahead. I won't say which is right is which is wrong. We're just going to run it all and run it and see. Right? We'll take a lot of guesses and we'll just run it and see what happens. Okay, and then I can explain what is happening.
I would guess that it's gonna print out Elijah and then go to back to the beginning, print out Matt, and then go back to the beginning and then a new line, because it flushes in the function. Maybe it's my guess.
Great. Okay. Yeah, Erica's got a guess in. Who else wants to take a stab at what they think is going to happen? You can just run it in your head. You have to practice running the code in your head. Okay, run the code in your head because these simple things you don't need an IDE, right? So you can run it in your head. Imagine, look at the screen in your mind's eye, saying, "Hey, all right, okay, that's what's going to happen." Okay, so you can say that. I think that's what Erica did too. So just take a guess. It's more. I want more guesses. Okay, it shouldn't just be one or two people in class coming up with these responses. Go on, be bold. No more. No other person wants to take a risk. Risk and guess what's going on or what is going to happen.
I don't think the code can run, right?
Why? Hang on. Let me see. No. Why wouldn't it run?
The hashtag include for IOStream.
Oh yeah. Okay. Thank you, Elijah. I totally didn't see it at all. I completely missed that. Okay, so you got to fix the. No. He's saying the hash include IOStream. It doesn't have angle brackets.
Yeah, the IOStream has to be in the angle brackets.
Yeah. All right. Okay. So now. Okay. Now guess.
IOStream without the S, right? Because
No
IO
S, no
streams.
S. Is there an S? All right, I'm going to change my glasses. Yeah, no S. It's just IO stream. Okay.
Also, does it matter that the /r is in double quotations and not single? Is that gonna?
Oh, no, it doesn't matter. Very good question. And very good question. Okay. It does not matter for a very important reason. The reason being that cout, that operator cout, can take different kinds of parameters. It can take an integer, it can take a character, it can take a string, everything, right? Yes. That is called an overloaded function. We will be doing overloaded functions in class, okay? So you will know what overloading is. An overloaded function can take different kinds of parameters because the compiler knows, well, this function was called with an integer, so I need to call a different version of that function. So there, an overloaded function has like 5 or 6 different versions of that function. There are, for all practical purposes, if you have an overloaded function, you can think of them as functions with different names. This is function A, function B, function C. So as far as the compiler is concerned, there are different functions. It'll make a decision as to which function to select when it's called by looking at the parameters and say, hey, the function got called with an integer, so let's call the integer version function A. If you call it with a string, it'll call the, right? So that operator actually has overloads for character as well as a string. And that is the reason it works. If you didn't supply the double quotes and you said single quotes instead, it'll just call the character version of the function. And yeah, oh, Peter is here. All right, so, and his friend, both the Peters. Okay, all right, so so what we can do is here. Yeah. Here, YouTube, right? So you can take it from there. Okay, so all right, so you just need to I'll close the door too because it's not quite warm yet. You can take that; it's over there. Let me check it, buddy. All right, so all right, so good question again, right? So thank you, Erica. So is everybody okay? Nobody wants to take a guess? Nobody, any more guesses? Do you want to run it now and see what happens? Yeah. All right, yeah, run. Oh, it still didn't run. Okay, yeah, well, who can fix this, by the way? Who can fix this? I mean, I don't want to be the, because I did this once before in a previous lecture. Okay?
Don't we need another library to do sleep?
Yes, and which one is it? Which one is it?
Is it IO manip? Or the IO manip one, or
No, IO manipulation is when you want to manipulate the output, saying, I need 4 decimal places, 5 decimal. If you want to manipulate the output, you need IO manip. But there's one more. We've used this with 3 or 4 times. We've used this in class before. Especially, for the kind of stuff that Erica is doing with sleep, right? Sleep is the one that's not working here. Okay, so what is it?
Is it UNI-std.h?
Yeah, thank you, Elijah. Okay, UNI-std. And if it's hard to remember, just think of this as Unix standard. Okay, just like C++ standard is Unix standard. There's a whole bunch of functions that in the Unix standard library that you can use in general C programs. Okay, UNI-std.h. I think you need to have .h for the ancient C++ C files. Okay, Unix is it's before predates C++. It predates C++. There you go. All right. Okay, that is the behavior I was expecting to see. Okay, now what did it do? Did everybody see what happened? Right, Erica saw what happened. Who else actually saw what happened when he ran it? Because he clicked it when I was hitting run, so you may have been listening or looking somewhere else. How about everybody look at the output now when he runs it one more time? Okay, everybody look at the output and tell me, and someone should explain to me what is going on. Okay, so someone explain to me what had happened. Not Erica, okay, and not Elijah. All right, so not Erica and Elijah. Someone else who hasn't had a chance to speak today. Try and take a stab at what do you think happened here? What did print actually? It didn't print Elijah. It didn't print Matt, but it printed Mata, right? So what's going on? Why? What's happening there? Come on, right? You got to take a stab at these things. Unless you're all checked out and, you know, and you're not really care about what's going on in class. You're just here for a physical presence. In fact, we used to say when we had real classroom classes, we used to say, well, you know, I don't know what's going on. I'm here as a warm body to increase the temperature of the room, right? Because it's cold and all. So, but we can't even do that in Zoom days because everybody's in your own home, right? So you can't say I'm here in class to increase the temperature of the class. No, I'm here. I'm still cold. I had to close the door and all, right? So, so you're not here to increase the temperature. Well, you got to tell me what's going on because you're in class. You got to. Yeah.
Just combining isn't it just combining the two of them together? Like,
why is it combining the two of them together?
Is it because of the /R, like it goes back to the start of the line, and so because Elijah has like the first four letters, like when it prints Matt, only the first four are changed, but the last two still remain.
Yes. Okay. All right. So, how many of you, you know, followed Namrata when she described this, or if you want a different rephrasing of it? Okay, I'm happy to do that. But did you all understand what Namrata was saying? Or do you want me to, right? Because it printed Matt, Elijah first, and then it went back to the beginning of the same line, /R, same line. And then it printed Matt there. So MATT, and you didn't give it any more stuff to print. So after that, so it just went to the next line. But, you know, Elijah had two more letters. And so those two letters are still there. Yes. Now, how can we fix it so that it prints Elijah and then prints Matt also without the AH on the end? How can someone tell me how you can do that?
Could we maybe print like a long empty string to kind of clear it out as a method?
Right. Okay. So so we can absolutely do what Erica is suggesting, which is to Erica, correct me if I'm wrong. So you're saying between the two prints, we also print a blank line, right? Lots of spaces and nothing in there. Yeah. And it has to have a lot of spaces. You can't just say a blank line has two empty quotes, right? Because if you print two empty quotes, nothing is going to happen. We can try it, obviously, right? So let's go after the sleep, just say print ID screen, right? And then yeah, print 1D screen, and then print a blank screen, print 1D screen, open quote, and then print two double quotes, empty string there, and put a comment there, put a comment on the right side saying, trying to clear the screen before printing the next line. And then within parentheses, you can say, this is not going to work, okay? Trying to clear the screen, and you say, within parentheses, you can say, not going to work. Okay, now if you run this now, you'll see the same behavior. You'll just see Mata again, right? So you can say, you run again, if you run it again, you'll just see Mata. Yes, because so what Erica suggested was you have to print an entire line of spaces. So you can just put lots of spaces there, Yeah, right. So now if you can print it. Great. Okay, so it did the right thing by erasing the AH also with spaces. So that's essentially what happened, isn't it? Now, when we're doing this, we notice that it's kind of messy for us to say, you know, print screen, how many spaces should I print? Oh, you know, it has to be longer than the previous thing and all. It's a mess. So let's try and make things a little more programmer friendly. Okay, so let's create one more function. So on line 19, line 19, hit enter and say print, clear 1D screen. Create a function called clear 1D screen. Okay, clear 1D screen. Yeah, and then yeah, exactly. No, it doesn't need any parameters, right? And here you can say cout, and then you can and you can print a whole lot of strings, you know, spaces, 80 characters. Let's say 80 characters. Okay, so yeah, print 80 characters, 80 spaces, right? Open quote, and then lots of space, 80. You know, you can go all the way up to the right margin, right? It has to be double quotes, by the way. You can fix it later. You can fix it later. More. Your comments are longer, okay? Yeah, get rid. You got an initial single quote. You got to get rid of that single quote. And then more spaces in there. Okay, all right. I think that's fine. Because otherwise, if you get too many spaces, what will happen is that it'll print that when you clear the screen, it'll print that, it'll wrap around and push the line up. Okay, so we don't want that effect too, right? So now instead of print 1D screen, that line 26, you can basically say clear 1D screen. Yeah. Oh, by the way, hang on 1 sec. Clear 1D screen. Oh, you need a /R at the end, by the way. I'm sorry. 21, line 21, you need a /R. So you need to erase everything and then go back to the beginning. Yeah. /R at the end. Right there, inside of the string. Inside of the string, you can say /R. Yeah. So what that does is that it'll print a lot of spaces and then go back. That's all. It's just erasing that entire line and going back. Now you can say after sleep, you can say clear. Yeah, on the next line, you can say no, on the next line. No, the unsuccessful one is first, and then the successful one. That's better, isn't it? So on line 27, Yeah. Now you can say clear 1D screen, and now we'll get the desired effect. Yeah. Okay, so that's great. Now here's something that we want to try and do. We'll also say that here is our 1D screen. Now, by the way, before we do that, and by the way, put a space above the main function. So on line 22, hit enter. Okay, so I want to make sure that everybody's on the same page here, because we're just taking baby steps, one little step at a time. Hopefully we'll have something that is bigger. Maybe it won't be bigger than 100 lines today, right? Most classes we're writing less than 100 lines of code, really, if you think about it. Yeah, so we'll get to that level of that length by the end of class, but I don't want to just go there and say, a lot of students are still there, right? So I want to make sure everybody is on board, because, especially since nobody's piping up. Okay, nobody's talking. There's only very few students, Erica and Elijah and Matt is typing, but I'm not hearing back from a whole lot of you. So you all got to be vocal. I know it's Monday morning and all, right? Why is it Monday? Why is Monday morning difficult for students? It's just another day for me, anyways, right? So you got to be. It's all the same. So you got to be active and engaged in class. Otherwise, there's no point in attending any class, not just my class, any class. Okay. So let's see. Hey, so is everybody okay so far? Is everybody on board with what's going on? All right, Mohammed is nodding his head. Okay, at least raise your hands. Okay, raise your hand, everybody. Jay, Anna, all right. Great. Okay, Charlene, you're here. Yeah. Okay, you raise your hand and okay, good. Okay, good. Okay, so here's what we'll try and do now. Before I explain, right? Before end of class today, someone should interrupt me if we're running out of time. And say, hey, you know what? We've played around long enough. We want to know what's going on behind the scenes. Can you explain what's going on when you call a function at the CPU level? Even though it is not critical for CS2A, it is important for C++ and knowledge of computer science, especially if you're majoring in computer science or intending to major in computer science in a different college. I know someone, Namrata's at UCSC or UCSB, I don't know, right? So, and you guys are maybe majoring in computer science. So these things are important, even though it's not in CS2A, knowing exactly what happens. Okay, so remind me and I will talk about it. And we also have Thursday, obviously, right? We can talk about it. In fact, why don't we do that, right? On Thursday, if we don't get to it today, we'll talk more in depth about what actually happens when you call a function and behind the scenes, and when the different kinds of parameter passing, what happens, all those things. All right, those we'll get a chance to talk about them more on Thursday. Okay, all right, so here's what we want to do. So we have the ability to take a screen and print it. We also have the ability to clear the screen. So what we want to do is let's say we want a function. Okay, let's say we want a function that is given a screen. Should we call it a screen? Yeah, that's given a screen and asked to place a pixel on the screen. Okay, very basic graphics. But actually, this is how graphics starts. Initially, we're doing 1D graphics. Later on, maybe even in 2A, 2A? All right, okay, we'll try. Okay, in 2A in subsequent weeks, we'll try and do 2D graphics. Okay, 2D graphics using these things. In fact, Hana posted some library, I think SDL or something like that, which is supposed to do 2D graphics. Okay, and we can actually develop that library, or at least not the entire library. We can develop some parts of it that we need in class, so that we don't have to use an external library. We just know how to do this, and we'll write the code for ourselves. So we can do that later on. So that's 2D. But many of the principles that you learn in basic graphics, like putting a pixel somewhere, or tracing a line from here to there and seeing if it collides with some other object already on the screen. All of those are very simple algorithms, isn't it? So, and you learn these things, but how would you do it on a 2D screen or on a 1D screen like this, right? So suppose I say I want to print a row of pixels. Let's say an asterisk or a star is a pixel, right? You want to print a row of asterisks and find out if it's going to collide with something that's already on screen already. Yeah, already on screen, right? So meaning that you're giving it a screen which already has objects on it, and you want to find out if you send a bullet or a ray, right? A ray of light, it's going to bounce off something. That's all, or it's just going to keep going and go off the end. So that is how you find surfaces in 3D space. Yes. Well, there's more interesting and efficient algorithms to find 3D, surfaces or hidden surfaces in 3D without having to do this laborious process of marching towards the surface and finding out whether you collide. There's interesting algorithms you learn, but essentially this is what we're trying to do intuitively at the intuitive level. What we're trying to do when we do things like in 3D, like hidden line removal, right? There's this cube I'm looking at, and these lines should not be seen because they're behind the surface. How do you find out, right? There's algorithms to find out. Very interesting and intricate and nice algorithms, right, that you can do. But this sets the stage for it, because you do whatever you do in 1D, slightly more sophisticated will be in 2D, right? Slightly more sophisticated in 3D. And after that, you can do the same kinds of algorithms in n-dimensional space, in hyperspace, without having to actually visualize it, because you know that all of these things work in 2D, all of these things work in 3D, and I can prove mathematically there is no cases when you introduce more dimensions. Then you can basically just let your program loose in hyperspace and say, well, you know what, I'm going to deal with n-dimensional vectors, because this machine learning project has too many variables, right? They're all independent, so they're basically like axes, right? You don't have 3 axes anymore. You have many axes, but they're all independent, and they could all vary. So you have a surface, but it's not a surface that you can see with eyes. It's a hyperdimensional surface, but it will behave exactly like a 3-dimensional surface if you can look at a projection. Yes, because you know how to handle these things. You can handle it in any dimension. You don't have to be able to see it with your physical eyes. You can see it with your mind's eye. I don't know, it's kind of starting to sound like pseudoscience here, but that's exactly what happens, really, isn't it? If you people think that, oh my gosh, these algorithms are really hard, and I think that people who say these algorithms are hard really they're saying that because they jumped right into that without having to without getting to it the right way, right? If they went to it the right way by learning all the little things and then looking at the big thing, all right, the big thing is just basically putting these little things together in these places, and that's how it works. Okay, but people who say I'm going to skip all these little things and go right to the big thing because I want to master the big thing, this is always really hard. And so don't make that mistake, and because then you'll be turned off from the field completely for no fault of your own, just because you skipped a few things. So we're just mastering these one-dimensional artifacts, not artifacts, these algorithms here. Okay, all right. So see out for clear 1D, we're done clear 1D. So let's do one more function under line 22. Hit enter. Under line 22. So hit enter. Hit enter. All right. So here's what we're going to do. Okay. So I'm trying to come up with a name for this function. Set pixel at. Set pixel at. Okay. Right. So all right. So let's say this function. Let's say it's going to return a Boolean. Okay. It's going to return a Boolean. It's going to return, and you'll know why. You'll find out why it's going to return a Boolean. Okay. Bool set pixel at. Set underscore pixel at. Underscore at, right? And then it's going to take 2 parameters. Okay, it's going to take 2 parameters. The first parameter is going to be the screen on which you're going to set the pixel, meaning that the user, the programmer, can have many screens they're working on. Okay, they could be working on 5 different screens, and at any time they can say, I want that screen to be shown. I want this screen to be shown. I want these screens to be shown alternately. Yes, you can do all these things because you can print the screen and clear it, print the screen and clear it, and you can have many screens. And that is in fact how a lot of 3D graphics that we look at on screen, right? Even I don't know if this is how they do it on televisions in the current. I think that's how they do it. Okay, so when you look at 3D graphics and smooth motion happening, when we so during the very early days when I was hacking and I was trying to do 3D animation, the object will show. And then the next object, which is that same object after having turned a little bit, okay? Because you need to have 16 of those frames every second, or 20 frames. You need to change screens 24 times a second in order to get the smooth animation effect, right? I think it's called, what is it called? Persistence of vision in our eye, right? So you need to have 24 or 16 frames per second, so that, because even movies, right? Even movies are not really moving movies, right? They're basically static frames that are shown so quickly that our mind is fooled into thinking that it is a continuous motion, isn't it? Because if you go to these ancient movies and you can get the film reel, right? You can go to the Hollywood and get these film reels. You look at a film reel and they're all just photos. They're all photos. There's like millions and millions of photos, one after another. They're transparent, right? And they're projected one after another. However, what happens is that it is very, very important that when you show the first photo, right? And then if the second photo is just going to slide into view like this, and the first photo is going off screen like that, does not work. You can try it out, okay? You can try it out if you have the first one, and then you're going to paint the second one on top without erasing the first one, then the animation effect does not happen. Okay, so what has to happen is that the first one is there, and then the first one has to be completely disappeared. Okay, it's disappeared completely. You need to clear and then print the second one. I was going somewhere with that story and I forgot. So I don't want to waste any more time, trying to reground myself. So let's go with this, and we'll do this later. Okay. So screen, and the screen, the parameter is going to be string type. Okay. Let's say it's a string screen. And let's leave it like this for the moment. Okay. Let's leave it like this. Comma, and then you say position, right? So position should be size t position. Yeah. Size t position. And in fact, what you can do is commonly when people just say pause for position. And the reason for that is because when a variable like position, very, very likely it is going to be used as an index for an array, all right, or a vector or something like that. And when you have an index within square brackets, people prefer to have little words or a single letter like I, J, K, right? If you have within square brackets, if you have a long name, it is unsightly in programs. Yeah, anyway, it's unsightly to me, and I know it's unsightly to a lot of programmers that I know too. So I'm generalizing here. So you know already that position is going to be inside of an index. So make it pause instead of position so that it'll look cleaner, right? So make it pause. Right. Now, here's the important thing that should happen in here. The first thing you got to do is inside here, you're going to check if the position is less than less than the size of the screen, meaning that the screen is only 80 characters wide, and you're asking me to set a pixel on the 100th character. Okay, that means I'll be writing into the screen in an area that is not owned by the screen. The screen only owns 80 characters, but you're asking me to set the 100th pixel, which is like, someone else's program, someone else's data. Yes. So what we want to do is if the position, in fact, we'll do something even better here. Okay. This is called an early exit. This pattern of programming is called an early exit because it saves cognitive space. What I mean by cognitive space is that anytime you're programming, I don't know if these things are useful to you when I say these. So cognitive space when you're programming is that, not just programming, any task you do, right? It doesn't have to be computer science. Is as you're doing things, if it's not an instantaneous job, you need to build up a working memory of what you've already done, right? Isn't it? Because you need to be on track of the cognitive. So which means that as you're doing things, you also have to keep remembering what you've done so that, things you do later on don't impact something you've done in a bad way. Yes or no? Otherwise, the whole thing is going to be tanked. Okay. So now, as you're doing more and more things, this thing that you have to remember keeps increasing. Yes or no? Therefore, the cognitive load in your mind keeps increasing as you perform sophisticated tasks with increasing depth. So what programmers I've found tend to do is they're always on the lookout subconsciously, okay? And they're not conscious. You'll see them. When you see programmers, expert programmers code, you'll actually just see this, okay? They're subconsciously looking for a place every time they can cut the cognitive load. They'll cut it right there, okay? And one way of doing this is called an early exit. An early exit is when you're working through a program and you've come to a situation where you know that, well, you know what? After this, it is a point of no return. If I continue, it's not going to succeed. So I'll just return false. Okay. They'll say exit false right there, or return false right there. That means it just shaves off a whole bunch of cognitive load from what they've accumulated, because there's something that they don't have to remember from that point onwards. Does that make sense? Excuse me, right? So anyway, this is something that you'll encounter and become familiar with later on. So what we're going to do, if pause is greater than or equal to screen length, instead of less than, okay, is greater than or equal to. In this case, it doesn't make a huge difference, right? But later on, you'll see that it makes a huge, right? Then you say on the next line immediately, you say on the next line, indent in, and say return false. Okay, that is called an early exit. And put a comment there, return false after that. Put comment and put a comment saying, this pattern is called an early exit. Look it up, right? And say, type it up. You can say, look it up on Google and discuss it. Okay, and look at and discuss the pros and cons. Okay, discuss the pros and cons, right? Benefits and pros and cons. Okay, and the other thing that, and one of the cues that programmers get for cognitive load, by the way, okay, and I think, I don't know, I've never seen this discussed in any textbook anywhere. Maybe nobody else has noticed it, or they've noticed it and they've just taken it, in the stride and say, hey, that's what it is, and nobody's talking about it. Okay, so one of the cues that I've seen programmers, or at least in my case, okay, not other programmers, is when the cognitive load is high, okay, there is a screen-based indicator for the amount of cognitive load. Not always, in many cases, you can look at the screen and the program, and at any given point in your program, you can say, well, you know what, at this point, if I'm coding this, the programmer, or if I was coding it, I would have this much cognitive load. Okay, at this point, I have this much cognitive. How can we tell how much load we're carrying in our head? And there is a useful proxy, not always correct. There's a useful proxy in our programs. If you're programming in a nice way, that is the level of indentation. Okay, if the level of indentation in your code shows you or represents indirectly, not in in an objectively measurable way, but very, very high correlation. So the level of indentation shows how much baggage, mental baggage, you have to carry with you as you're coding. Meaning that if you're indented in 5 levels and you're coding here in your code, that means there's a lot of conditions here. A lot of conditions. Anything could go wrong. Yes. So something you're doing here, could break any of those things. So those are things that programmers tend to, shy away from, saying, oh, I want to guard against that kind of thing happening. So they're always averse to indentation. Well, yeah, I shouldn't say averse to indentation, because programmers love indentation, right? If you go to Python, it doesn't even compile the code if you don't have right indentation. Yes. So indentation is good. However, despite indentation being good, programmers have this. I'm always saying programmers, okay? And just take that with a grain of salt, because it's just the limited subset of programmers that I've encountered or worked with, or myself. Okay, just say it's just me. And the other thing, oh yeah, before I forget. Okay, Ben Stefanik. I don't know if any of you are doing courses in psychology in our class, in our department, in our college. Ben Stefanik is one of our psychology instructors. Okay, so he is doing a survey. He's doing a survey, and he's asked for help from every professor in college right now. And he's doing a survey. His students are doing a survey on the effect of this thing called chat GPT or something like that. Yeah. So which is AI, which apparently does homework, or you can ask it to write an essay and it'll write an essay or things like that. Now, a lot of instructors at Foothill, or maybe even other colleges, they're concerned that it increases chances that students don't turn in legit work, and it could be we can't tell and things like that. So many other faculties, many other people are worried And so they're doing a survey. For me, I don't think my style of teaching is at risk at all from that. So I don't care, because, I don't teach, I do the traditional Western model of education, I think, in the Western world anyway, is giving you lots and lots of facts to remember and testing your memory and whether you follow the rules. Okay. And I think that kind of education system can only go a certain level, right? It can cross the barrier where real knowledge needs to be imparted. Okay, so but fortunately, I've had the experience of learning in a way that does not use that method. So this method of learning does not teach you facts. In fact, it gives you lots and lots of wrong facts too. Right. In fact, I'm giving you lots of wrong facts. Right. When I say things, I'm telling you things that are completely subjective sometimes. And many of the things that I say, try it out, may not even work. Okay. So in fact, it doesn't matter if your work is from ChatGPT or it doesn't matter. It could be wrong. So the goal of my classes is not to give you information and rules to follow, but rather to train your mind, because you have in you the capacity to distinguish between what is right and what is wrong. Right? So that is what the education system needs to focus on. The education system needs to say, I'm not going to give you lots of facts. The facts are out there. I can prevent you from getting facts. You just go to the internet, you'll get a million facts and more than that. Yeah. So why am I wasting my time, taxpayer resources, in trying to combat these people, these technologies that could potentially undermine what I'm doing? No, right? Because that is not my job. So my job as a teacher is to instill or sharpen, right? Sharpen the students' own mind. They've already come in with a sharp mind, but they don't know it is sharp, or they just need to be oriented so that they can tell what is right and what is wrong. And then it doesn't matter whether you use ChatGPT or not, because even if you get the solution from ChatGPT, it doesn't matter because you will know, well, I got it from there because I got someone to do it for me, but I know it's right. Okay, so that is what is important, because you'll get problems and you need to be able to solve it, but you won't be able to solve it if you got a copied solution from somewhere else. Okay, so and in fact, the other thing also with all these technologies and AI, I think this is just my personal opinion, right? People say, oh, this needs to be combated, and we need to have measures in place where we can test if that if the worker actually did the work themselves, or they got an AI bot to do it for them, right? Technically, it's possible. In 10 years from now, I could say, as a manager in a software company, I could say this needs to be done. Go and do it. And then the worker could say, they go to a autoprogram.ai or something like that and say, I need this algorithm to be coded up, and these are the constraints, and they come back with an algorithm and submit it. Okay, so and then the manager could say, well, you know what, I'm paying this guy 100K or 200K per year, and they're not doing anything. They got a pet AI robot in their home that they're doing all their work. Okay, so how can employers police against these things? Okay, so the only way to do these things is, I think, eventually to assume that everybody is going to have a perfect AI robot at home. Okay, that is where we're going. Everybody will have someone who is a genius, right? A genius at home, essentially, right? Can we handle that situation? That is the answer that people that are trying to fight ChatGPT and all these things, that is the question they need to answer. Okay, let's try and address a situation where everyone on Earth has a pocket robot that is, universally intelligent. Well, not universally, but up to some limit. Now, can we handle that situation, right? So the only way in which we can handle that situation is to say, well, you know what, we're just going to pay people for, or recognize things that work. Okay, it doesn't matter how you get it, which means that, if people are going to turn in AI solutions, it's just that everybody will be doing this because it'll be cheap, which means that the price will come down, market driven, isn't it? So, these programmers won't get paid hundreds of millions of dollars anymore because anybody could do it. Now the price will come down, and people will say, well, there's not enough market for doing these AI things anymore, right? Well, AI is good, but I need to do what is more than that, or try and come up with something that they can't do. That is where the money will be. And so the problem is self-solving, as long as we are not wedded to the notion that the only way to run the world is by imparting rules and saying, this is how you should do it. This is how the prescriptive world will be ruined by AI. But a descriptive world, which basically tries to live the best life we can at any point, given the constraints we have, that will always try and find the best way to live. That's evolution. That's how, and nature itself works, I think. Anyway, by the way, where was it going with all that? Is that Ben has sent out a survey. I think you may have got a link from your other classes already. If not, send me an email and I'll send you a link to that survey. You need to respond to that survey. Well, you don't need to, but please do, right? Please do, because Ben is collecting statistics and it'll obviously help many of these other classes, right? Maybe in history and all, it's much harder, I guess, for professors to say, it was an essay written by ChatGPT or a human, because it's just you have to put facts together, and they have to look at what the inference was, the inference drawn, and things like that. But it gets harder. So please do take the survey. I also told Ben that I will let all my students know. So please pass this message on to all the other students, saying that if you get an email link with a link to a survey from any of your professors, please complete the survey. Okay. All right, great. So here's what we want to do. So that's a return false. Okay. Also on the next line, after line 26, you can hit enter. By the way, it's not cognitive, it's cognitive. So you got an extra N before the G. Actually, get rid of the word cognitive load. This is just I just used it. Okay, I don't think there's anything called cognitive load. I just made up that term and I've been using it. So yeah, I think that's good enough. So on the next line, you can say screens square bracket. No, it's not part of the if statement. It's out of the if statement. Yeah. Screen square bracket pause. Screen square bracket pause. Pause. Screen square bracket pause equals. Now we can use a single character, okay? Because we're assigning to a single character, you can't do a double quote anymore. So it's got to be a single character. So within single quotes, you say star. Okay, star is our pixel. All right. So now we will come back to this and make some changes, okay, with default parameters and so on. Now we can go to the main method, All right, and I'm going to leave this. No, I'm not going to leave it. I'm going to ask you guys to do it while I'm watching, or maybe maybe you tell me if you don't want me to watch. I won't watch. Okay, but here's what you need to do. And Erica is not allowed to participate in this because I think she's done this already once. And who else? Okay, not Erica, Hana, Namrata. Okay, so other people can do this. What we want is basically, I want to see a star. Okay, a star starting in the left edge of the screen and gradually moving. Okay, one step at a time, one per second. Okay, it needs to move one step at the end of each second. Yeah, I don't know, 50 columns. All right, 20 columns. 20 columns, 20 seconds already. 10 columns. Okay, 10 seconds. Okay, your program needs to run for 10 seconds and it has to have a star. And as you're looking at it, the star is moving physically, even on online GDB. Okay, even the star is physically moving on your screen. Bam, bam, bam. At 1 second intervals, 10 spaces. It's going to take 10 steps. So get rid of what you have in main right now. So in your main, and we'll put a comment right at the top. Of main, inside of main. You can get rid of everything inside of main. Yeah. All right. So now you can put a comment there saying to do, uppercase to do, uppercase to do, one word, colon. To do colon. Yeah. All right. So print a moving star. Okay. Print a moving star, like that green comment. Okay. Print a moving star that steps 10 spaces at 1 second intervals. Okay, that's all right. So what do you have to do before and by the way, Matt, someone else may call the code and you type it in. Okay, you're not unless you really want to come up with the code yourself, but it would be nice if someone else calls the code and you type it in. Is that okay with you?
Yeah.
Great. Okay, so someone else is going to call the code. So let me know how the general structure without coding. Tell me, what is the general structure? What is generally going to be happening here? What kind of structure are you going to use to do this? Okay, so I'm going to call out people. Okay, now because nobody's responding. How about Jay? Okay, Jay, can you tell me what you may try to do here in order to get that effect? Right, we want the effect. That's the effect on line 32. It says that's the effect we want. how may we go around trying to get that effect?
I'm not really sure. That's actually what I was trying to figure out.
Okay, that no worries. Okay, that's okay. So you'll find out. How about Minghua? Minghua, you tell me. How about Minghua tells me?
Would you do like a for loop or 10 steps?
Great.
And then
Excellent. Excellent. All right. So Jay, that's basically what we're going to do. We're just going to do a loop, a for loop, and inside the loop, we're going to print the star, sleep, star, sleep. Okay, except that the position of the star is going to keep changing every time. Yes or no? Jay?
I mean, yeah, that makes sense.
Yeah, you are. Yes, if it makes sense, that's good enough for now, because as it's implemented, the making sense will solidify. By the way, you kind of migrated all the way to the right side of my screen. You're not in the middle of the screen anymore. Only half your face. All right, that's much better. Okay, all right. So this is what we're going to do. So someone is going to call out the code. And Matt, yeah, hang in. I'd like for someone other than, well, how about Minghua, or let's say Mohammed, or Nam, you're not here, or Charlene. Charlene already coded. Okay, Nam, are you here? Because every class I see you, but you're not responding. And your camera is not on either. Nam? Well, I was hoping that Nam would call out the code. How about Minghua already said that, right? How about either Yu Yang or Mohammed? Who wants to do it? Who wants to call out the code for who's typing? Matt, right? Either Yu Yang or Mohammed should call out the code, and Matt will type. Okay, he's already typed some of it there. But and by the way, you need spaces on both sides of the equals. Okay, you only got space on the left. Right. So who wants to call out the code? Either Mohammed or Yu Yang. Who wants? Right? Or I'll just name one of you. So if you don't raise your hand, I'll just name one of you, and you have to do it. Okay. So who wants to call out the code? This is a for loop with these two statements in there. Oh, two, or I don't know how many more. Right? Raise your hand. Raise your hand, please. Mohammed, you want to do it?
I'll try.
Okay, all right. So why did you raise your hand? If you said you're going to try, you should say, I want to try.
I don't really know what to do. That's why.
Doesn't matter, okay? Because you see that, Matt has already started typing, and then there's all these other classmates to help you. We'll all call out code. So just take, important thing is to keep trying, whether you're going to succeed or not, keep trying. Because, like I say, in quest number eight of green, quest number 8 of green. So if you, the guaranteed way to fail in anything is to not try, because there's a guaranteed failure. Whereas if you try, it's not a guaranteed failure. You may still fail, but it's not guaranteed anymore. You can succeed. You have a chance of success if you try, but if you don't try at all, it's a guaranteed failure. I can bet against that. Okay, right. So go ahead, Mohammed. So you're going to call out the code, and Matt will type.
Go to another line. Like hit enter. Then I think it's C out. Then the lesson sign and star, then quotation mark star. Then do end L at the end. Then I think then you hit answer again, then do sleep. And yeah, that's all I know. That's where I get stuck.
Yeah, but it's got the important things in there. Not all of them. It's got some important things in there. So that's good progress, okay, already. So does anybody want to take this and modify it a bit more so that it is moving towards the actual thing, the solution that we want? Yu Yang, do you want to take a crack at it? Yu Yang?
Can you use the set pixelet function for the star?
Hey, are you? I can't see your lips moving, but you're.
You can't hear me? Let me put on my.
Yeah, I can hear you. Wow, I thought it was Zoom. No, you were actually moving your lips very slightly. I think I just couldn't see because of my glasses, maybe. All right, okay. Or a ventriloquist. Maybe a ventriloquist. All right. So yeah. Go ahead. Did you want to do it? Did you want to fix it up? You want to fix this up? Yes. Thank you.
I guess for the for loop, we can do size t, I equals 0, I smaller than 10, I plus plus. And then for inside, what you do, I'm not sure. I'm guessing you use the set pixel at I, and then you sleep for a second, and then you do the clear screen function. Use the set pixel at square bracket I. Is that how it works? Or yeah,
So if you run the set pixel at, it's gonna return a Boolean true or false, right? So we have to do something with true or false.
So no, we don't usually have to. It is good to have the return value to know if the pixel set succeeded or not. But if you are sure that something is going to succeed, then it is safe to ignore the return value, whether it's Boolean or right. You only use the Boolean when we are going to do something we're not sure about, and we need to know whether it succeeded or not. So that's why we have the Boolean return. But in this case, you can make the for loop in such a way that we know for sure it's going to succeed. So how about I walk you through this code, and then it'll be very clear. And if you have any questions, I'll explain to everybody. Okay. So here's why I think. So let's go above the to-do line, below the to-do line, right? Hit enter. Let's create a string variable. Okay. Let's create a string variable that is going to be our screen. Okay. String, and call it screen. Because I saw that Yu Yang was using this variable called screen, but there's no variable in there called screen. So we're going to create it. Now equals screen equals, right? And then lots of spaces, because we want to start with a blank screen. Yeah, okay. All right. Yeah, I think that's fine. We're going to change all these, make this all professional looking by, moving things around and refactoring in the end, but we'll leave. Yeah, right now screen, comma, you want to place the pixel at position I. Yes or no? Right. So now, yeah, comma I. It's comma space I. Now you can get rid of the C out above it, because we don't want to output anything to the console directly. So we're going to, right. So now that screen has now got the pixel set at the ith position. The next thing you want to do is you want to take that screen and print it. Yes. So do we have a function for print? Yeah, there you go. Print 1D screen. Yeah, screen. Yeah, semicolon, and then enter. And you have your sleep one. You have to sleep for a second, right? Sleep for a second. Now, this is not going to work. This is not going to produce a desired behavior, but yet this is an intermediate point where we get to somewhere, it works, but it's not exactly what we wanted. So we have to make one more change to make sure it works. Okay, and then more changes, refactoring and cleaning up and all, but it's not going to work. So can someone tell me, don't run it. Right? Can someone, we have to resist the temptation, right? Programmers have to resist the temptation to keep running their code all the time, because then, the more you run the code, the less you run it in your mind. So let's run it in our mind to see what do you think is going to happen now? If Matt runs it, what is going to happen? Take a guess. All right. So you run the code in your head. Say, all right. So I'm setting the pixel on that screen, and I'm printing that screen, and then the next I. So I'm going into that loop and doing that repeatedly, right? So what is going to happen? What is the visual effect you'll see? What is the visual effect that you're going to see?
Is the whole line going to be stars? Because there's no clear.
Minghua, you said something?
Is the whole line going to be stars? Because there's no clear.
Right. Okay. Right. Someone else. Right. I don't think everybody heard what you said. So which means that is good. Someone else can have a guess too. Right. So another person. I'd like another person to guess what is going to happen. Karthik, can you guess what's going to happen? All right, you're sick. All right, how about Rijay? Rijay, can you guess what's going to happen now? All right, don't worry. Okay. It's just practice, okay? What I mean by practice is practice running code in head. Okay, running code in our heads just comes by practice. That is why also, again, you got to keep on programming, because when you keep on programming, you'll start running without your knowledge, bigger and bigger chunks in your head, because your fingers are lazy. Anything that needs mechanical motion, your body will automatically try and see how much of this can I do in my mind. Yes, anything we do. So keep on programming, and more of the code will automatically, without your knowledge, be getting run in your head. So that is why practice is important. Practice is important in any art. Okay, so someone else, maybe someone else. Otherwise, I'll say, yeah, Hannah. Let's leave. I know you know how to do this. Okay. So how about Jay? Jay, I want to go for people who may not know, right? Because I want to get everybody on the same page before moving on, right? Jay, can you take a guess what's going to go on? Why is it?
Well,
is it going to be different?
Yeah, isn't it true that for all those spaces to be made, there's going to be stars there now? Or no?
Okay, all right. Yeah, I
The
think
pixels will be set
that is
there.
right. Yeah, I think both Minghua and Jay said what's going to happen, but the effect that we'll see is they said the entire line is going to be full of stars. That's what, isn't that what you said, Jay? Right, and I think that's what Minghua also said. Okay, but the effect you'll see is that it's not going to be one line of stars, bam, like that. The effect you see, in my mind anyway, is one star basically growing like a tree, right? Not like a tree. One star getting longer and longer. One star, two star. So you'll see stars, but the star will grow to your right? So you see 2 stars, 3 stars, the line will grow in stars. Okay, that is what I think is going to happen. So that we can fix. Later. Okay, after we see that effect. Even though it's wrong and it's not the desired effect, it's important to run it so that we'll get practice and see what's going on, so we can go back and fix it. Now we can run it and we'll see if that effect actually happens. Yeah. Oh, don't put the clear there yet, right? Comment out the clear. Comment out the clear for now. Yeah, because that's what we're going for, right? We want to see the effect and then we can clear. Oh, what's going on? You got a for loop that is not terminated. No, where is the line? Control reaches end of non-void function.
Yeah,
oh, I
it's the
see. Yeah,
Boolean.
line 20. Oh, yeah. We didn't return true at the end. We have to return true there. Did we run it one time before and it did actually run? No, all right. So we have to return true, right? You have to stop it and then return true. Right. Now I think it will run now. Semicolon, yeah. Oh, why? Wow. Okay, why is it not? It's going to print a whole line of stars at the end, maybe? No, wait a sec. What's going on here? Right. Other people should be trying to debug this with me. Okay. Why is it not? Show me. I got to see the code. Thank you. Yeah. All right. So why is it not doing anything? Set the pixel, print the screen, sleep, and the print also flushes. Yes, it flushes. Print contents and then a /r and then it flushes. Oh, that's funny. And it actually just waited for 10 seconds and it. All right. So after print 1D screen, after the line print 1D screen, just print a cout endl. Just print on line 36. On line 36. Yeah, just do a cout endl. Let's see what the hell happens there. Yeah, run it. Oh, it's just printing. Oh, set pixel. Where's this? And it's supposed to put a star. Where's set pixel? Where's the set pixel at? Okay, so the bug is in our set pixel. Okay, so screen dot length. If it's greater than it returns false. That is correct. Otherwise, it puts. Oh, yeah, of course. I know what. So this is so cool. This is so cool. All right, this is so cool because we now have an opportunity to talk about something about functions, which I was planning to talk about only after about 15 or 20 minutes. Okay. All right. So it is very important that I'm happy that this happened. Okay. The reason it didn't, we're not saying this, is because in C++, there's two ways in which you can pass a parameter to a function. Okay. One of them is called, that's very important, it's going to be tested in the midterm. And by the way, again, a point that I made to my 2B and 2C students, some students apparently seem to think mistakenly that this course is all about the quests. You got to do the quests and understand the quests and do all the quests up to 9 and you're done. No, the quests are only a small part of the course, as you know, if you read the syllabus, right? You got a whole lot of modules. You got modules to read, and the modules are also, the Michael Losef modules. They also have week numbers, so which means that you need to be reading and digesting these modules in parallel with doing the quests. Quests are just homework. Okay, that is not the major part of your CS2A or B or C, right? So quests are homework. You read the modules, understand the modules, and then when you understood the modules, the quests are meant to be an opportunity for you to test whether you've understood the modules correctly. That is the way in which this entire thing should be done. This entire course, 2A, 2B, 2C, is people can't just jump into the quest and say, okay, I'm going to do this. I'm going to look up some resources and get past these mini quests and I'm done. No, that won't. Maybe you'll get a pass, but not a good grade. Okay. So you need.
I had a question about that. So like, because you also have like on Canvas like the week topics. Do the topics match like the content of the modules too?
Most of the time they do. Okay, most of the time they do.
And when they don't, we refer to the modules.
Yeah, you have to refer to the modules. What you can do is for the midterm and the final exam. For the midterm, just all the modules that are numbered 1 to week 6. I think it's week 5 maybe, right? Because the midterm is technically in week 6, right? Yeah, modules 1 to week 5. The material in that needs to be solid. And then the quests, and the quests will help you. The quests will help you nail down the material in the modules. That's the way we should look at it. Okay.
Okay. So to week 5 then, not week 6.
Yeah. Because week 6 I think is about objects.
Yeah. We got into OOP and I was like, wait, do we?
Yeah. If you do get questions about objects in the midterm, you just let me know. We'll reinstate the points for those. I don't think there are any. I took out all the questions in the question bank regarding objects. Yeah. So week 1 to 5, you got to master in the modules, right? And I think I explained it. You read the modules, copy the code, put it in an IDE, run it right there, and see if you're getting the same result that the module says you should get. Okay. And then even after you get the same result, I say, all right, now I've got the result. I'm going to try and change this. I'm going to try, the module says this is the code. I'm going to change the I from -1 to +1 and see what happens. All right. Have to experiment. 4 or 5 different experiments with each module snippet you see in the code snippet you see in the modules. That'll really solidly nail down all the concepts. Yeah. So that's the way to study any computer science. And like math too, right? You can't just open a book and go through the proofs. With computer science, you need to open a book, read the thing, but as you're reading it, you also need to try it out. You can try it out and say, that's why it doesn't work, and so on. Okay, all right. So there's 2 ways in which you can pass parameters to a function. A parameter to a function is saying, here's what time is it? I need to talk about 9:20. Okay, yeah, 9:30. I think I'll I'll talk about this. Talk about only this thing, okay? And then we'll wrap this up. And next week, next class on Thursday, we'll talk about what actually happens when a function is called. I don't think we can do this today, because we'll wrap this up, and we'll come back. So the 2 kinds of ways in which you can pass a parameter to a function, right? One is copy, right? So one is passing by copy, and the other is by passing by copy or passing by value, right? The other one is called passing by reference. Okay, this distinction between the 2 different ways of passing parameters is very unique to C++, and it is in many ways one of the core powers of C++. Okay, and it is worth getting to the bottom of and understanding exactly what happens. Okay, here's what happens. When you pass, anytime you pass a parameter in a C++ function, okay, the function does not get the original parameter. It only gets a clone of that parameter. It gets a copy, meaning it'll get the value of the parameter, but not the actual parameter. It is a very important distinction and a subtle distinction. All right. So if I say to a function, you know, here is the number 5. I'm gonna pass the parameter 5. Okay, my x is 5, and I pass x as a parameter. That function, which receives x, is not getting the actual x that I sent it, but it's just getting the value of x. It's getting 5, but it's not. It may be called x1 inside the function. Yes, it's a completely different variable. It's a different variable altogether. It's a copy, which means it's really powerful. That idea, that concept is very powerful, because that means that function is free to do whatever the hell it wants with that parameter. It will not affect the original x. Yes, it will not affect the original x, because it's passed only by copy. The original is safe in the caller's hands. Yes, does it make sense? Now, why is this important? Because you don't have this in other languages. Like take Java, for example, right? In Java, if you have an object, a complex object, and you're passing that object to a function, I don't know if people are familiar with Java, maybe in Python too, right? You get a reference to the object. So that object, when the calling function fiddles with the object, this caller function who sent the object there has got to be, jittery and sitting on its toes. I hope that guy doesn't fiddle with my original object, because I sent the original guy over there. Yeah, if that guy changes the object, my original has also gotten changed. Now when that situation happens, that is a huge amount of cognitive load to the programmer, because when you call a function, you can't really be sure that everything is okay until the function returns with the object, right? Because you sent your most precious guy over there, a mafia hitman, right? They send him over with a message, right? In those days, that's how kings send messages to other kingdoms. They gotta be, you can't say, right? They could do anything to the messenger. So you can't send the prince is not sent as a messenger. The prince is here. The prince will pass the message on to a messenger who is dispensable. Okay, the messenger goes. That is what happens in a function call in C++, right? What the calling function, right, has is deemed to be precious. Okay, it will not be sent to other people. The other functions, unless you explicitly, the caller, the king, right, when you decide I want to send the original object, you have the option to send it. But if you don't send the original object, only a copy of the object will be sent. Okay, how cool is that? It is very important, because that distinction, you can leverage that distinction, do really cool things in C++. Because I know, right, if you have a complex data structure and you pass it, sometimes we'll come across situations, right? There are situations when you want to hold on to the object. All right, here's a classic situation, right? There's two different ways. So suppose you have a big movie file, 10 gigabytes or something, right? 10 gigabytes or something. This is an example I've used before, and the students actually said it worked for them. So I'm high chance it'll work for you too. So please pay attention, right? Pay attention. So you have this big movie file, 10 gigabytes, and you want to count all the scenes, right? All the scenes in which some famous actor, let's say Brad Pitt or someone, right? So I want to count all the scenes. Each is a frame, isn't it? They're all frames, static frames. I want to count all of the frames in which Brad Pitt is there, like a captcha or something like that. So now, obviously, the logic for that is very complex. It's not sophisticated, because you got to break it up and do these things. It's going to be, some big ass function there. Now you have a choice. You can either send the whole movie over to the other side and say, count all the scenes in which Brad Pitt appears and tell me the number. Or you could say, here's a copy, right? And you can copy, right? Now, when you send a copy, you don't care, because that person could, cut out all the pieces and the film is destroyed, but you get the actual number back. So it's two different ways. So in that situation, it actually makes sense to send the original and not a copy. Yes, because it's 10 gigabytes. You don't want to you just want someone to copy, count the number of frames in which Brad Pitt occurs. So you say, well, it's just a simple operation. All I need, and I don't want to copy 10 gigabytes over, send it over, and then, they got to send 10 gigabytes back again. That's a huge overhead. So to avoid that, I want to pass by reference. Now I have the option to do what Java does by default and say, well, in this case, I want to pass the original object over because I don't want to waste time copying 10 gigabytes. I'll pass the original object. However, C++, even in that case, gives you the option, right? You can send the original over, but if you're worried that the other side might change it, you can tag the original with a const, okay? Which means that the original goes, but I'm sending my own son. The king says, I'm going to send my own son, the prince. The crown prince is going to come as my messenger to you, but he's going to come in a heavy armor. You can't do anything to him, right? So that way you can say it's const. Okay, I'm going to send the original object, but I'm going to tag it with the const. You tag it with the const, the compiler will say you can pass by reference the original object, but I'll make sure that that guy, the calling function, does not mess with it, doesn't tinker with it. So if the calling function tries to change it, the compiler will say, hey, no way, I'm not going to let you change it because the caller said this is a constant object, you can't change it. Okay, so C++ gives you the opportunity and a way in which you can pass either the original or a copy of it, and the copy is default. Okay, in other languages, the copy is not default. Passing the original is default. And in fact, I think in many other languages, if you want to pass the original, it's not easy. In C++, it is easy, right? So if you want, we just say, I want to pass by reference, the original goes, right? So, and by copy, it's easy, but other languages, you'll know, right? When you're doing other languages, you'll find out there's differences, and that's one of the powers of C++, is that you can pass the original. So in this case, what happened was that, where's that thing where we set the pixel? Yeah, set pixel at, okay? Set pixel at line 35, okay? We're saying, set the pixel on the screen, okay? And you're passing the screen as a string. But in fact, what's going on is that screen is not being passed. A copy of that screen is being passed, okay? This screen is untouched, and that pixel is being set in the copy. And then when that function returns, that copy is destroyed anyway because it was local. Now your original screen was untouched, and so you only still have blanks all the way through. Does that make sense? Okay, it's such a simple thing that happened on screen today, right? But it actually embodies a very, very important concept: passing by reference and passing by copy. Now we can fix this by telling the compiler, right? Tell the compiler, dear compiler, I'm going to pass a screen to you on which inside of that screen I want to set a pixel. However, I want to pass a screen by reference, not by copy, okay? So you can tell the compiler that this parameter is the original, not a copy, okay? How would you do that? All you have to do, right? Very simple. All you have to do is go to the signature, line number 24, line 24, okay? Line 24, where you say set pixel, string, space, screen, yeah? All you have to do is put the ampersand sign in front of the word screen. In front, right? Before, yeah. All right, that's all you have to do, right? If you do that, that means the screen parameter is not a copy anymore. It is the original. So anything you do to it will be reflected. So now if you run it, you'll actually see the desired effect. Well, not the desired effect. You'll see the growing line of stars, okay? Oh, so why is there an endl? We have an endl. Oh, yeah, the debug endl. Right, get rid of the line 37. Line 37. Triple click and delete. Triple click and delete. That's the easiest thing to do. Triple click and delete. 3 clicks, delete. Yeah. All right. So now if you run it, you'll see that growing line of stars. Does that make sense? Now that's all we did, right? We just inserted the ampersand, and that it made a world of difference. Because now it said, I'm not sending you a copy of the screen. I'm giving you the original screen. If you make a change to it, that change will be reflected on my screen too. Is everybody okay with this? It takes a little while, right? It's not like it's going to take a long while, like getting to, manipulating pointers in a linked list. That'll take like several, maybe several hours, maybe even a day to properly understand. Of thinking about it, not reading about it and coming back after a day. That'll take a long time. This will also take not that long. Maybe, I don't know, 10 or 20 minutes of just staring at it and thinking about it. It takes that much time to understand. That is the difference, okay? The difference is that it is passed by reference. That is called passing by reference, okay? Now, on line 24, on line 24, put a comment. No, actually above line 24, hit enter. Yeah, hit enter. Right, comment there saying this function takes the screen parameter passed in by reference. Parameter is no E at the end of parameter. Oh, there's an E after the M. Parameter passed in by a reference and indicated by the ampersand. On the next line, you can say indicated by the indicated, and then on the next line, you can say by the ampersand in front of the word screen. By the ampersand, in front of the word, and let's not call it screen, just call it SCR, just to make it very clear that it's not the same variable. Okay, just call it SCR and change S and the parameter name also to SCR instead of screen. SCR, and also pause greater than on line 27 and line 29. Line 27 and 29 also change screen to SCR. 29 also. Right, so it's a different parameter. So ampersand in front of the word str. Okay, now after that comment on line 25, put a full stop and say what should I say? Yeah, research more and share on the forum. Research more and share on the forum. Yeah. This is called passing by reference and passing by value. And if you want for help for the people who are going to look at the video later or look at the code within code, passing by reference, passing by value, you put that in a comma within parentheses for people to just copy and paste in Google, right? You can put that in Google and they'll get lots and lots of examples. Okay, now we need to put that clear thing back. Now we'll see that on line 41. If you do that clear, now you'll actually see the effect that we originally wanted, which is the star moving like that. Why is it not? Oh yeah, okay, all right. So we need to do one more thing. Okay, we're clearing. What we need to do when we clear is our clear function itself needs to be different. Okay, our clear should also clear the screen. Yeah, our clear should also clear the screen. Now, right now, it's not being given a clear and a screen to clear. So what we need to do is clear 1D screen and pass it the parameters. Let's do the function first. Okay, clear. It's going to get passed a parameter by reference. Okay, so void clear ID clear 1D screen, and inside of that say string ampersand scr, just like before. Ampersand scr ampersand str. Okay. Now Now on the next line, inside of the loop. And there all you need to do is just do a loop, right? Just do a loop there, get rid of the line and just do a for loop, a really tight for loop through the length of the string. Okay, for I equals 0, I less than str.length, I plus plus, and all you're going to do is set each character to a space. That's all you're going to do, right? So scr square bracket I equals space. Does that make sense, everybody? No. Space equals space equals space. And double quote, single quote, space, single quote. Yeah. All right. Okay. So now, wait. Clear screen. Yeah, on line 42, we're calling clear 1D screen, but it needs to be past the screen as a parameter. Yes. No, SCREEN. Your screen is called screen. Yeah. Okay. I think that should work, shouldn't it? Okay. So that is the effect we were going for originally. Yes or no? So far, are things clear so far? We'll make a few cosmetic changes to the program now, and also refactor it nicely. so that it's nice, and also set us up for next week, because we'll use this code. Okay. So Matt, after we're done today, you're going to post the link to the code on Reddit, because we'll pick up this code next class and then do more embellishments, and maybe we'll have an idea for a game then. Okay. All right. So here's what we're going to do. Now we're kind of hard coding a number of things here. Like, we have this thing and all. So what we'll do is print 1D screen. All right, so let's go, and now we're going to define a let's define. All right, so screen. All right. All right, so let's do some cleanup. Okay, this is all cleanup. We have the logic and everything working. We're just going to do some cleanup here. So inside of main, on line 35, hit enter. Yeah. Now let's say const space size const space size t space screen width equals 80. Now actually, you know what, screen underscore width, but I'm thinking it shouldn't be here in main, because you got to, if it's in main, you got to pass it the width to all these other. The width is already encoded in the length of the string, right? We want a string that is what I'm trying to do here. You guys can think about it, and maybe you can do a better version of it on Reddit when you post it. What I'm trying to do here is I want to have a constant that says this is the width of the screen, and then I want a string that is that wide. All right, let's get rid of that for a moment, right? Let's not go down that path, because I can't see a clean way to do it easily. Right, wait a second. Okay, that's our screen, arbitrary length. We don't know how wide it is. All right, now passing the string, clear the screen, print 1D screen, print contents. And in fact, also, let's do one more. Where you say print on line 15, where you say contents, change the word contents to SCR. We will use the same variable name all the way through for parameters. Yeah, SCR, and also on the previous line. So SCR, all right, string contents. And let's do one more thing, right? And now, because we know that the print 1D screen is not messing with the parameter. It's given something and it's doing something with it, but it's not messing with it. Yes. So why? So as a programmer, you will think, well, if it's not messing, if this function is not messing with that parameter, why should I take a copy of that parameter and pass it? Because making a copy has overhead. Yes, it takes time, especially if the object is big. So here you might say, well, you know what? Let's not make a copy. I'll pass the original string even to print. So what you can do there is even turn that line 15 print 1D to take a screen passed by parameter reference. So you can put an ampersand in front of that SCR2. Yeah. However, here's where we're going to use one more thing that we learned. Okay, that's really cool. All these things falling into place. Okay. So, however, even though they're both taking passed by reference, we know that Mr. Main, right? So the main method knows that even though I'm passing the screen by reference to both of those functions, only one of those functions is actually going to change the screen. The other function is not going to change the screen. Yes, because set pixel at is going to change the screen. Clear is going to change the screen. However, print is not going to change the screen. Yes. But I'm going to pass by reference to all of those guys because I don't want to waste the overhead. Well, I'm going to pass by reference. Yeah, I don't want to, in print case, I don't want to waste the overhead of copying the screen. So I sent the original. However, I want to send the original with an armor so that that person, Mr. Print, cannot change it. Okay, and you do that by inside that parameter on line 15, before the word string, say const. Okay, const. Okay, now that says, now we've got all of these things that we talked about, passing by reference. Lots of places to experiment in this code. Okay, try and find out. I changed this, didn't work. Changes, and this is why it didn't work. So many places to experiment. So it's like a gold mine for you for experimentation. Right now, this says I've passed the string by reference. It's the original, and then print 1D string screen should not change that parameter because it's tagged const. Now try changing that parameter inside it. So say on the next line. Say try changing it, right? Say screen square bracket 0 equals some random stuff, right? Yeah, put some random stuff in there, and the compiler will catch it, right? The compiler has your back. It'll say, hey, Buster, no, I'm not going to let you run your code because you're trying to change something that the Mr. Main didn't want you to change. Yes or no? Is that what it says? Screen?
I think it's to do SCR.
Oh, it's SCR. No, SCR. Okay. Now it'll say, hey, you're trying to change something you're not allowed to change. Does it say that? What does it say?
Couldn't you just do SCR equals, or like, do you have it in
He
the
did it.
square brackets?
He did it. He did it. Oh, I'm sorry. Wait a sec. Oh, by the way, you're assigning to a single character on the left, right? But so on the right, it should be a single character, not a string. No, it's still a string. Within double quotes is a string. Within single quotes is a character. Within single quotes, right? I'm surprised that it didn't pick up on that error, right? It should have picked up on the error, but there was a different error it picked up on. This is the error it picked up on, but it should have picked up on the other error too, right? So you're trying to assign to the string, and it did pick up on the error. And it said exactly what we expected it to say. It's saying, hey, you're trying to assign something. You're trying to change something that is only read-only, right? Read-only means you got it, you can look but not touch. That's what it's saying, right? If you have a const word there, it says you can look but you can't touch this. So it's read-only. Whereas the other two functions, which also take screen passed in by parameter, by reference, they also have the ampersand, but they're allowed to change because they don't have the constant tag, right? That is the power of the constant tag. Now, you may think that is, oh, it's so simple. Constant tag, I can live without it. It is a great boon because right now it seems like it's not doing a great deal of things, but later on you'll be writing programs in which you get a constant, constant reference passed in. And that function could be calling another function. Yes. So it could pass that thing to that function, and that function could be calling another function. So there could be a whole lot of functions that that this gets passed to. You don't know who's getting passed to. It could be getting passed to a lot of functions. So you can already imagine if the programmer had to keep track. I'm going to pass this original the original function parameter to that function. And if that, I got to make sure that function doesn't change it. Well, one function, maybe you can look at it visually and fix it. Okay. However, if that function calls other functions and those other functions call other functions, you can see how much of a hairy problem it becomes automatically at that point, right? Because you're saying I'm passing the original, but my prince who went there without armor, I can make sure that is a friendly kingdom. They're not going to harm the prince. But if that friendly kingdom is going to send my son to a whole lot of other kingdoms, but they're not the parent anymore, so they may send my son over to these other kingdoms without sufficient protection, right? So how do you know? So that means this king who originally sent his son over to a neighboring kingdom needs to be mindful and saying, well, not only do I need to be careful that my friendly guy doesn't harm my son, but I got to be sure that all the other places to which my friendly person sends my son to, all of those other places are friendly too. So I now have an enormous cognitive load on my head, right? Because I need to make sure that all the other places that my friends were going to visit, my son's going to visit, they're also, right? So it's hard, isn't it? That is where the const keyword comes in really, really handy, because once you tag something with const, it is like, it's like a tattoo on the prince's head, okay? It is tagged, meaning that no matter where the prince goes, no matter where the parameter is passed, from here to another function, everywhere, the compiler can keep track of it for you, right? So that is the beauty of the IDE and the compiler. They'll take that load off your head, off your back, and say, well, you know what? If you tag it with const, I'll take it from here. How beautiful is that? Okay, you have it tagged with const, and the compiler says, I got your back. You can forget about it now. I'll make sure that this function doesn't change it, and I'll also make sure that if some other function gets past this guy from that function also cannot change it. It'll go to the end of the world to make sure that function is no function will get changed. It can change that. Okay, that's a really, really powerful feature. I don't know of a keyword in Java that does that, right? I think there's something called final in Java or something like that you can. I don't know if it can be used in all contexts, but you can do this in many other languages, right? If you try and change things, it'll just change, and then you're left with a surprise result from your program, and it won't happen. Okay, so there you go. Now I think if you can get rid of, now you see how it happens, right? You can get rid of line 16. Or you can comment out line 16, comment out line 16, comment out and put a comment on the right saying, now this will not compile because SCR was declared as a const reference. Yeah. Reference, right? And then because is U instead of Y. And I think that's good. All right, so print once screen. All right, so that's all done. Print screen. Yeah, that's really cool. What else? What time is it, by the way? Oh, it is time. It is time. Right. So yeah, all right. So I think we covered some very important concepts today. What I'm going to suggest that you guys do. This, by the way, if you compile and run it, it should run. It should run, right? If you run it now, you'll see the star moving. Great, excellent. All right. So here's well, potentially extra credit, but here's something that you can extend this and post in the share on the Reddit. Okay, so and if you're not able to do it, that's okay, but you should at least give it a shot. You have with you now all that you need to create a simple game. And if you don't do it, let's do it. We will do it next class, but please try and do it. If you do it, we'll try and take what you've done and try and add more to it, right? So in this game, you're going to have two-player game, okay? Two players starting this side and that side of the same line, right? Let's say there's an A here and let's do one more thing. Okay, one more thing. Just one small thing, and then we can call it the end of class today. All right. So I want to do something called a default parameter. Okay, default parameter. So set pixel at, right? Set pixel at after size t comma pause. Right? After size t comma pause, put a comma. No. On line 29. Line 29. Line 29 at the end. After pause, put a comma, right? And say char, char, right? Space, pixel equals, char space pixel equals, within single quotes, put a star. Right? No. On line 32, where you say equals that star within single quotes, just say pixel. Okay, what that does is that it gives three parameters, but the third parameter, you see that it's slightly different declaration. It says equal something. What that means is that there's a default value of 0 or star. In this case, it's star, right? That's a default value for that parameter, which means now the compiler creates two different versions. Even without you writing two different versions, it creates two different versions of the function. Same function. One function has two parameters. The other function has three parameters. Okay. And if you call it with two parameters, it will automatically call the function with the three parameters with the star, because the star is default. If you call it with a third parameter, you can say, I don't want to call it with a default parameter. I want to call it with a special parameter. Maybe it's a dash. So if you print a dash, now you'll see, if on line 40, where is set pixel at? On line 40, right? After the I on line 40, at the end of line 40, yeah, put a comma and say, let's say, we want a dash. Yeah, put a dash, okay? Put a dash within single quotes, right? And then put a comment on the at the end of the line saying, the dash is a default parameter. I actually put dash within single quotes because it says it looks like it's part of the sentence now. Yeah, dash is a single quote. Yeah, it is a default parameter. It will be default parameter. If it is not given, dash is our parameter. Dash is our parameter, and not default parameter. Dash is a parameter. Is our parameter. Dash is our parameter. If absent, the function will use the default star. Comma star. Yeah, they are default star, and then turn the absent comma into a full stop, and then capitalize the T after that. is our parameter. Is our parameter full stop? Yeah, there you go. All right. So now if you run it, you'll see a dash moving. All right. I think you'll see a dash moving from left to right. Okay. All right. So here is the challenge for you, right? So the potential extracurricular challenge is that you're going to have two players, and they're going to start off on two sides of the line, right? Maybe have an 80 character line, right? And then you'll have player A. You can use A now. You can use A for player A's pixel and B for player B's pixel. Okay, they're going to start off on the two ends and maybe mark the middle of the line with a star or something like that, or a vertical line, something like that. Okay, put a vertical line in the middle. Now, at 1 second intervals, these two guys are going to start moving towards each other. Okay, and the first person to reach the bar in the middle is a winner. Now, how do you determine the speed at which these two guys are going to move? Initially, you can say, I'm going to choose a random number. Okay, well, say this guy's going to wait 1.2 seconds between runs, between steps. That guy is going to wait 1.3 seconds between steps. Okay, walking speed is different. Then you can find out who gets faster. Now, once you've got that working with different speeds, now you can take that game to the next level and say, how can we determine the speeds? Now we can take that 1.2 and 1.3, and instead of being random numbers, we can say, type these characters fast, and then, on the keyboard, and then we'll determine a number from the speed at which you're typing. Yes. So now you can say, all right, now we got a real race. We got a real race in which, the people are going to type. Well, you don't have to do the typing part, right? Just pick random numbers. Two guys getting random speeds assigned to them, and they're just going to keep moving towards the center. Okay, and then when one of them hits the bar, you can say, well, A won because A got to the bar first. That's all. That's all. It's very, very simple. And once you've got that done, we'll try and take that, say, hey, we'll try and do something more to it. So, or maybe take that into our, more ideas will come eventually, right? So next class we'll say, we'll type, the speed at which the players are going to move towards each other into the game, so that you actually have something really, functional and also fun. Because I think that might actually be a game that potentially students, people at a dinner table can play, right? You can have a small game on an iPad. You got to, to type two characters really, really fast as you can, and that is going to determine the speed with which your guy is going to move. And the next player says, okay, now I'm going to do this, right? That's the speed. Nobody knows what the actual speed is because they all know, I just type fast enough. And then when the program starts running, it'll actually say, these guys are going to move at that speed, and then you'll see who's faster. And I think it'll be really cool. If you're not able to do it on your own, we'll do it next class on Thursday. Okay. But that's basically it. Was this class useful? Did you guys learn some new stuff today and interesting and useful stuff? Yes or no? Yeah. Good. All right. Thank you. Thank you for your time and for your patience. Everybody will get a chance to code eventually. Okay. By Matt, thank you. Was it useful today? Coding, Matt? Where's Matt? Yeah. Was it useful?
Yes.
Great. Okay. See, when you code in front of other people, it is like coding 5 times on your own. And my grandfather, when I was young, he used to tell me, writing once is equal to reading twice, right? And he used to always say that to me when I was trying to memorize things. He said, no, write it down. It's the same as reading twice. But here, coding, writing in front of 50 eyes looking at you is the same as reading 50 times, right? Because so many people are looking at you, you're going to be like super duper careful. And so this is really, really useful exercise. If you haven't coded in front of other people, you should absolutely take every single opportunity to do that. Okay, especially when you're a student. So I remember everyone who's coded. So I'll go through the people in class who haven't coded, give them opportunities. Karthik, I hope you get better and you're getting ready to code next class. Maybe on Thursday, we'll try and take this and try and make some more changes to it. Okay. Thank you all. Have a great rest of the day. Remember to do the survey. Okay. Try and look for the survey, or send me an email for the link, and I'll send it to you. And best of luck. All right. I'll see you guys later. Bye.